Very good. Thank you so much, Wendy. Appreciate the forum. I appreciate everyone taking the time to be here this morning. I'm sure we're all pretty tired of COVID-19 and how things have been going on. But I think that first I'll start out and say, when we look at the question I've asked in the title, did it help our COVID-19 response? And the answer is a very qualified yes, and we'll talk more about it. I also just want to mention that in the sections on what is working and what didn't work, I've got about 14 references there, and I would be more than happy to share those, to share anything from this presentation with you. Just drop me an email and I'll send it to you. I've got a list of the citations and a summation of each one. So when we look at AI and machine learning, I think what we want to do first is really look at what it is, what AI and machine learning is, and let's do a little review. And for those of you who are in my AI session last year, this will be a little bit of a review. I think what we always have to keep in mind is that artificial intelligence and machine learning are kind of together in this central area right up here: artificial intelligence, deep learning, machine learning. The idea of deep learning and machine learning are pretty much the same thing, unless you're a PhD candidate at MIT, and then you've been able to parse out how many angels can dance on each one of these pins. But it's part and parcel of artificial intelligence. We have to keep that in mind. But artificial intelligence, isn't alone by itself. Artificial intelligence by itself is no more than a bunch of algorithms and some code. You also have to have some of the different disciplines around computer science itself, software engineering. You've got to have databases available. You've got to do a lot of data mining. You've got to have big data analysis. You can't do what we're doing over here without some big data. So with all those bits and pieces, and throw in having some statistical chops and understanding mathematics, and then some types of neural computing, at this point you really have to look at how many skills do I need before I can do this. Now there are lots of tools around. There have been a number of successes within artificial intelligence, but we need to keep this in mind. And artificial intelligence, as I like to tell people, is really based on the Lisp language, which was a list processor. And that language, as an interpretive language, was developed before Fortran. So this is a language from the 1950s. This is a language that's 70 plus years old. So we have to look at the fact that this has been around a long time, and it's taken a number of different platforms to allow us to use it today. Comparative, when we talk about artificial intelligence, we talk about machine learning, we talk about big data, pretty much these have gone along in kind of the same steps. From what's interesting is looking back at November through about a week ago, or 2 weeks ago actually, the middle graph here, you can see that these are pretty much tracking right along. If we look at February and March being the time when COVID hit us, there's no changes. I mean, the trend line is pretty flat. So you have to understand that the work that we've been doing during COVID-19 is work that has been carrying on for a decade at least. And a lot of what we're looking at is there has been a contribution, but we have to be really careful when we look at how do we quantify that contribution? How do we quantify the contribution that these make to what we're trying to do if we're fighting COVID-19, if we're trying to understand COVID-19, if we're just trying to decide, is today the day I'm going to mask up and go to the store? There's lots and lots of issues in play here. So back to what works in artificial intelligence. Speech recognition definitely works, although I'm sure many of us have had some very interesting experiences with Siri, with some other voice-activated tools. You want to be very careful with what happens. Speech recognition dates back from the 1950s when AT&T, Ma Bell pretty much, not pretty much, but was a monopoly. And at that point in time, they started taking audio tapes of how we Americans talked throughout America, whether you were in Boston, or whether you were in Savannah, Georgia, or whether you were in Albuquerque, New Mexico. They were taking that and building up how to understand the way we Americans speak English. Graphic processor units, digital signal processors, 1990s, these were the basis for computer vision. We couldn't do computer vision, and we actually couldn't do any artificial intelligence without digital signal processors. They're absolutely, positively necessary. They're little processors that we can fine tune. I can go on and talk about DSPs for days, but that's one of the things that within graphical processing units, within voice processing, within computer vision, you have to have a DSP. Neural networks. Neural networks are basically the idea of biomathematics, treating mathematics like the networks of neurons in our bodies. So what are the network of all of the different parts of our bodies as we play together? Well, we build up neural networks, and through those we can do decision making. We can literally ask questions and move back and forth and decide through the different layers. Neural networks are just basically bundles of nerve endings that are replicated mathematically within the computer, and I can move through the different layers of the network to get questions answered that I want to have answered. When we look at big data, when we look at machine learning, I need big data to do a good neural network. I need machine learning and intelligent machines in order to host my neural networks. Big data, we've been worrying about big data since the 18th century. Thomas Bayes' Bayesian analysis, we're all pretty familiar with that, and big data has been around for a long time. And then finally, the idea of machine learning was coined by Arthur Samuel in 1950, again, part of AI programming. So what we rely on today and what we're relying on for analyzing COVID-19 is really a...
Hi there, I hope you enjoyed that last clip. My name is Michael Maludis, and if you'd like to watch the full 60 minutes of that last webcast, while also getting complete unlimited access to our entire library of IT learning, simply visit our subscribe page at greatpro.org/subscribe. Unlimited annual access is $199 per year, but if you use the coupon code LEARN2EARN, you can drop that membership fee to just $149. That's less than $13 per month for unlimited access to over 1,000 hours of on-demand career development, covering the entire spectrum of IT management best practices, including business analysis and requirements, software development, quality and testing, risk management, process improvement, project management, and even digital transformation. But your membership doesn't just give you unlimited access to our vast learning library. You also get free access to our mobile app, as well as direct access to our network of over 300 of the world's leading IT consultants, all of whom are dedicated to putting practical knowledge at your fingertips so that you can learn more and earn more. I hope you will join me in becoming a member of the Great IT Professional and advancing your career with us. And if you're on YouTube, don't forget to hit that subscribe button above so that you get notified whenever we publish new free webcasts each week of the year. Thank you for your time and best wishes for your continued success.